Okay, so systems of equations word problems. I think this is one of the most useful ways to solve word problems of a lot of different types. So even some word problems that you've learned other ways of solving can be solved like this. Okay. So here's an example of a word problem that could be solved using a system of equations. Two small pitchers and one large pitcher can hold 8 cups of water. One large pitcher minus one small pitcher constitutes 2 cups. How many cups can each pitcher hold? Okay, so there's a couple ways that we know this is a system of equations. Right? One thing that we're kind of looking for is we have different variables, right? In this case, we have a small pitcher and a large pitcher. So we have two different things that we're looking for. And that's one clue that we can solve this through a system of equations. Another clue is that we have more than one piece of information. So usually that means more than one sentence, right? We have this sentence that tells us 2 small pitchers and 1 large pitcher can hold 8 cups. And then we have this other sentence here that tells us 1 pitcher that's large minus a small pitcher has 2 cups. And so when we have kind of 2 variables, 2 things we're looking for, and 2 sentences or 2 pieces of information about those things, that's a good clue that we can solve this as a system of equations. Sometimes, and I don't think you'll see this much in Algebra 1, but going forward into Algebra 2, right, maybe geometry, you'll see even larger systems. You could have 3 variables and 3 sentences. You could have 4 variables, right, and a whole bunch of sentences that helped you solve for each of those. You could have 5 variables, 6 variables. As long as you have enough information, you can solve all of those types of problems. Right? So this is what's called a 2-by-2 system. And that means there are 2 variables and 2 equations. 2 variables and 2 sentences in our work.
Can I guess what it is?
Don't guess. We're going to go through the whole process.
Well,
So,
I figured it out.
okay, cool. 2 small pitchers and 1 large pitcher can hold 8 cups of water. Let's just look at that sentence. How would you write that in math? Yeah.
2s
Okay.
plus L equals 8.
Okay, I like to write my L's in cursive in math, as long as we can see that. Okay, so 2s plus L, so 2 small pitchers plus 1 large pitcher equals 8 cups. Nice. Okay, second sentence. How would we write 1 large pitcher minus 1 small pitcher constitutes 2 cups of water? How could you write that as a mathematical equation? Go ahead.
L minus S equals 2.
Yeah, so all we're doing really is just reading through the sentence. 1 large pitcher, that's an unknown. So we've chosen to make that L. That's a variable. Minus, that's pretty clear. That's going to be just subtraction. And then a small pitcher we've chosen to make S because that's something else that we don't really know the size of. So we can't have a number to represent that, and there's no operation. Constitutes is just one of those words that means equals, right? They constitute, they make up, they equal, they can hold. All of these things just mean what in math we would write as an equal sign. And then 2 cups of water, we don't have to worry about the unit, cups of water. We just worry about the number, so 2. So we did the same thing up here. 2 of the S, and usually means plus, 1 of the L, so we just write L, can hold equals
Doesn't
8.
and sometimes mean like times?
Could, I guess. Can't think of an answer to that off the top of my head. Do you have an example of when it would mean times?
Like, I don't know, but something like that in homework. Maybe not.
Okay, I'm going to not use the green marker. Alright. So now let's look at these 2 equations. And what we have really is just a system of equations. 2s plus L equals 8. And then L minus S equals 2. Okay. There's a lot of ways that we could solve this. We could use substitution or elimination. It doesn't really matter. I'm just going to go for substitution because I noticed that if I add S to both sides, then I have L equals 2 plus S. That's another way of writing my second equation. So then I can just substitute this for L here. I have 2S plus 2 plus S equals 8. So this and this came from my first equation, and then this just substituted in for L from my second equation. So I've combined the equations, I have one variable, I can now solve it. 2s plus s is 3s, and then I still have my plus 2 on this side. If I subtract 2 from both sides, 3s equals 6. Divide by 3, and I have s equals 2. Plug that in. I know that L is 2 plus S, so L equals 2 plus 2, because S is 2, L equals 4. Since it was a word problem, they said how many cups can each pitcher hold? I would write out my answer as the large pitcher holds 4 cups, small pitcher holds 2 cups.
Yeah.
And then I would put it inside of a box so that Nate can easily find it on my homework. And then now, the trick with systems of equations word problems is that they're all going to look very different, right? It's not like a type. Up until now, I think a lot of what you guys have seen and been taught are types of word problems. Rate word problems, distance word problems, odd integer word problems, right? Where Gary puts 3 consecutive odd integers equal, the sum of 3 consecutive odd integers equals whatever. And it turns out that even a problem like that can be solved with a system of equations. One thing that I'm not going to do today, but that I would really encourage you guys to do on your quiz and on tests, is to check your answers just by plugging the 2 numbers back into your equation. Right? So take those two numbers, plug them in, make sure they work in both equations. Right? The other thing that I noticed, but I didn't say this, I should have said it, was that the large pitcher held more than the small pitcher, so that makes sense, right? You don't want to get an answer, like if we had gotten the large pitcher holds 1 cup and the small pitcher holds 7 cups, I probably did something wrong, because that doesn't make any sense. Right? Or it's possible that the problem was written wrong too. But use clues like that in order to check your answer to make sure it's right. All right. Second question. A test. So Graham, were you right?
Yes.
Cool. Had 20 questions. Worth 100 points. The test. TF is true false, right? A test has 20 questions worth 100 points total. The test consists of true-false questions worth 3 points each and multiple choice questions worth 11 points each. How many multiple choice questions are on the test? So they're only asking us for one thing here, but we actually do have two variables. What is the second variable? So the first one that they're asking us for is how many multiple choice questions? So the number of multiple choice questions is our first variable that we need to find. And if you think about this being the first variable, what would make the most sense as the second variable then? Multiple choice questions is the first one. So yeah, the number of true-false questions is our other variable. Okay. So sometimes in a problem like this, it's helpful to actually write down your variables. So I'm going to use T for my true-false questions. Right? And you could even write the number of true-false questions. And then I'm going to use M as the number of multiple choice questions. That way I know when I use those variables what they represent. So I need to write two equations because I have two variables. Right? What two equations could I write? In this case, it's not quite as clear as the previous question. I can't just read through this sentence and write an equation from it. A test has 20 questions worth 100 points. The test is not one of my variables, right? And 20 questions, that's combined, so that's not quite what I need. But what information could I use from that sentence to write an equation? Yeah?
With the 100 points, maybe?
Okay, I'm going to have to use 100 points, for sure. Any ideas on how I could use that to write an equation? Yeah?
T plus M equals 20?
Okay, so you're using this part, right?
Yeah.
The 20 questions, right? I know that the number of true or false questions plus the number of multiple choice questions has to add up to 20. Because there are 20 questions, and of those, there's only true, false, and multiple choice. So T plus M, the number of true, false questions, plus the number of multiple choice questions, equals 20. There's one equation.
Oh,
T plus n equals 20. How could I use other information to write a second
do the points,
equation?
right?
So the points. So what would I do?
Like 3p plus 11p equals 100p.
Right, 3 times my number of
Something.
true-false questions plus 11 times my number of multiple choice questions has to add up to 100 points. So just 100, right? Because our numbers in this represent points. So 3 times the number of true or false plus 11 multiple choice. So 11 times the number of multiple choice questions. It's going to give me 100 points that are on the test. A lot of times you'll see questions, so I'm going to do kind of a side note here. A lot of times you'll see questions that involve money, right? And they'll say like, you know, Tim has $2 and he has 10 dimes and the rest nickels or something, and some nickels. How many nickels does he have? Okay, so we're not going to actually solve this one right now, but the idea is that it's in a similar way that points on a test get multiplied by the number of questions. In a money problem, you would multiply, right, the nickels times 5 times n, to figure out how much money that's worth, right? But if you did it like this, 5n, each nickel is worth 5 cents, right? And if he has $2, how many cents is $2? 200, right? Because it's $2. $1 would be 100. So we would have to say, you know, 5n would equal however many dollars, so like 200. And I didn't set that up right. But the idea is that the number of nickels is your variable. So 5 times that gives you the money. And on a test, it's the same thing. Our variable is the number of questions. So t is the number of true-false questions. So 3 times t gives us how many points those questions are worth. All right, so we've set this up. Let's solve this one by elimination. I'm going to multiply below that, the top equation by 3. All right? And I'm just going to write it down here. So I have negative 3t minus 3m equals negative 60. And then I'm going to add these two equations together because I have 3t and negative 3t, which I know will cancel. They'll cross out. So that equals 0. 11m minus 3m gives me 8m. And then 100 minus 60 leaves me with 40. If I divide both sides by 8, I get m equals 5. And actually, that's all they asked me for. But if I were doing this on a quiz or test, I would keep going. Right? I know m equals 5. I'm going to find t. So t plus 5 equals 20. T must equal 15. Even though I don't have to know this, I'm just doing it to see if this actually works. Right? And then to check it, I would plug this in to this equation. 3 times t, so 45, plus 11 times m, so 55, equals 100. And that's true. So you could check it. So don't stop just because you have the answer. Keep going. Check. Make sure it makes sense. Make sure it fits into your equation. And then write your answer as a sentence. There are 5 multiple choice questions. And and pay close attention to what they're asking for. What if they had asked, how much is the multiple choice section worth? What if they had asked it that way?
How many?
What would you need to, yeah, multiply this 5 by 11, and we would have found out that section is worth 55 points. Okay, so just pay really close attention to what you're being asked at the very end. Right, and check your work, plug it in, go back to it. Any questions about these? So, there are some keys that I kind of went over, but I didn't explicitly write them down, right? You want to figure out what your variables are. That's a really important first step. Like, what are my two variables? What if we had thought, I'm going to make t for test as one of my variables? It wouldn't have helped me at all. It wouldn't have made any sense, right? So I have to kind of look, what do I have information about? Well, I know that these questions are worth these points. I know that I'm looking for the number of these questions. And you'll start to notice some patterns as you do several of these for your homework. You'll start to get better and better at questions like these. Because there's really only so many types of them. So you'll see stuff that kind of repeats. And use those patterns to help you. Like I was talking about with the money and the test. Those are similar in some ways. That's kind of a pattern. Look for patterns, identify your variables. Any questions?